We're at gotomath.com working some calculus. So let's just click on the button here. We're in the evaluating limits numerically, and we're actually in that section right there. So let's just kind of scroll up here and take a look at, that's not the problem I want to look at actually. There it is right there. Okay, we're going to be evaluating this limit numerically. So if you don't even know what this is, don't worry about it. I will try to clear that up a little bit at a time. Just kind of sketching this problem down real quick here, which I should have already done. Okay, let's move over to the whiteboard. And that's kind of off a little bit, isn't it? Can I get that on there? I'm going to need that here in a second. Okay, so we had the limit as x approaches 7. It's the way this reads, of 4x squared, and then it was minus 1 over 4x minus 1. Now I'm going to write this function notation here where f of x is actually equal to what we're evaluating our limit to approach there. Okay, and really it's not interesting at 7, but it's actually interesting at 1/4. If x was approaching 1/4, that's where it's actually interesting. But let's kind of sketch the graph out of this thing, and the way I'm going to do that is I'm going to factor something out of here, cancel some like terms. This thing can actually factor, this is a difference of squares up here, and this is going to be really important actually in the next section. Over 4x minus 1. Alright, as you can see here, we can got a term in the top that's the same as one on the bottom. Those actually cancel out. Now, it may be difficult to know what this graph here looks like, but we can now look at this and say, oh, well, what's left? 4x plus 1. Well, I know what that graph looks like, or at least I have a good idea of what that graph looks like. And right, so it has a y-intercept. We'll say that this is 1 right here. And so it's just a straight line that crosses and the y-axis there. And we're going to say down here that this is 1/4 down here, okay, for a good reason. And then I'm going to put like a missing point right here in the graph, because that's where it's undefined. Okay, so like I said, if x was approaching 1/4, well, this is kind of where it's interesting here. And this section is evaluating limits numerically, and that's kind of basically what we're going to do here. And the way this works is, so this is not going to be to scale obviously, but we're going to say 7 is right here. All right, so the y value out, or whatever 7 is, and we plug 7 into our function right here, and then we get something out. We could actually plug 7 in just right here. So 7 times 4 is 28, 29. So this is actually 29 right here. But with the limit, now that's evaluating f of 7, right? We said was 29, I hope. That's right. F of 7 is 29. Well, when we evaluate the limit, it's actually going to be at 29 also. However, this concept of plugging a number in and getting a number out is completely different than what this is doing. Okay, what this is actually doing, it's telling us as we get closer and closer to 7, let's say for example from the left, our y value is getting closer and closer to 29. And if we come in from the right hand side, our value is getting closer and closer to 29. And what we mean by that is what we can actually do is we can do this numerically, and that is I'm going to pick a number that's close to 7 coming on the left hand side. And so for example, if I took 7 and I subtracted off zero point 0.1, right, that's the same thing as saying f of what, 6.9. So in other words, I'm coming in from the left, and what happens is here, and of course we get some number, right, and it's going to be close to 29. But then if I said, okay, let's do 0.01, so we're going to have f of 6.99, right? Is that right? Okay, so as you can see here, we're plugging numbers in and we're getting really close to 7 coming in from the left hand side. Now we don't ever plug in 7 here, okay? We just plug in numbers that are close to 7, like 6.999, right? Okay, and that's what the limit is doing. Now this is coming in from the left hand side. They call this if we were evaluating finding a left hand limit, we'll talk about that later. And then we want to come in from the right hand side, so this is going to be 7 plus 0.01, which is actually, whoops, that's not what I meant to do. I meant to put a 1 here. 7 plus 0.1, so this would be 7.1 f of 7.1, okay, and then taking that and plugging it in to this guy right here. You can plug it into that if you want, whatever, same thing. And then if we had f of, okay, so we're getting closer and closer to 7 coming in from, and then of course, you know, we would plug that number in here and see what we get out. And we're coming in from the right hand side, okay? And so what's happening here is when we come in from the left hand side, right, we can see that that our y value is getting closer and closer to this number here, right? And we come in from the right hand side, so what we're doing down here, we can see that we're getting closer and closer to this point right here. Well, you must be asking, why do we even need to do that when we can just take 7 and plug it in and be done with it, right? Well, what about this guy right here? We got an actual missing point. If you took 1/4 and you plugged it into this, all right, you're going to end up with 0 on top and 0 on bottom, and then that's going to be a problem. So the thing breaks down when you plug 1/4 in. But if we came in from the left hand side and got really close to 1/4 like we're doing here, and then coming in from the right hand side, we can actually see where this missing point is actually located. We can actually determine where this point is actually at. And so that's really where the real power of the limit is finding out, you know, where is this guy? And we're just going to approach 1/4 from the left and approach 1/4 from the right. So you got to kind of wrap your mind around this whole approach thing. I know it took me a while. And of course, there's actually a definition of the limit that at some point in time I will actually add to this. But let's hit the help section here, and you'll kind of see what's going on. So the same thing here is the way I've gotten it out is we'll approach 7 from the left hand side, okay, and as you can see, right, so as you can see here what's happening, this number is getting closer and closer to 29, and of course approaching 7 from the right hand side, we do it from the right hand side, so we can kind of conclude that this guy is, and since both these numbers are the same or converging towards the same number, we can conclude that that our limit is going to be 29. And so that's what the limit is. So we just plug numbers in and we get really close coming from the left and coming from the right. And if both those numbers are the same, then we can say, converging towards the same number, we can say that this limit, for example, is equal to 29. Now that's all you got to worry about. That's all what the limit is about in this section. And we're doing this numerically. Okay, so it's not that bad. All right. Okay. See you on the next problem.